Hello. Today we are going to be working with literal equations. When you have a literal equation, it's just an equation that is all variables or majority of it is variables. Literal equations are equations that have two or more variables involved, and they usually represent some type of a formula like in math, science, and engineering. The problem must tell you which variable to solve for. And then you can just solve them as if you would any other variables, as if they were numbers. Okay, so here's two examples. One is a single variable equation, which is what we've been working with all along, and the other one is a literal equation. So let's go ahead and work the single variable equation first. So I look at this and I see that I have a variable of x on the left with a 3 and a 7, and then I have a 16 on the opposite side of the equal sign. And so I see that this is just a two-step equation. So just like normal, I would subtract the 7 to get rid of the 7. And that would be 9 equals 3x. And then because the 3 and the x are being multiplied, I'm going to divide by 3. And x is going to give me 3. These steps that we've done is going to be very similar to what we do when we have more than one variable. So on this one, our literal equation is 3x plus 7y equals 15. And they want us to solve for x. So basically what I want to do is get x by itself and on one side of the equal sign. So when I take a look at this, and I'm trying to decide what I want to work with, I see that the 3x is already on the left-hand side, and so it's just easier to leave it there. So I'm going to move this 7y from the left side of the equal sign to the right. And the way I do that is by moving this entire term. So since it's addition, I'm going to subtract 7y from both sides. And I'm going to get 3x equals a negative 7x, because there's no x's, and so 0 minus 7 is negative 7. And then I'm going to bring my plus 15 down. The reason it's typically written with the variable in front and the constant at the end is just that it places it in an order that you'll be working with quite frequently, and so it's just kind of nice to get it in that order already. Now we see that x is on the right, or on the left, but it isn't alone, so I need to divide by 3 to get that x by itself. And so if I'm dividing this by 3, then I'm dividing all of this by 3 as well. And so x is going to be equal to negative 7x plus 15 divided by 3. And then this is what x equals, is the negative 7x plus 15 divided by 3. This is the answer. This is simplified as much as I can get it. So let's practice using some of these formulas that we have. We have volume equals length times width times height, and they want us to solve for the L. So what I want to do is I want to get this L by itself. So I'm just going to rewrite it. So we've got V equals length times width times height, and we want to solve for the L. Well, this is all multiplication, correct? Length times width times height. I can get the L by itself by moving the W and the H. And since these two could be moved together, I'm going to go ahead and do that. So I'm going to divide both sides by WH. So when I do that, the W's cancel out, the H's cancel out, and I'm left with volume divided by width times height is equal to the length. If you look at example 2, you have perimeter equals 2 times the length plus 2 times the width, and again they want us to solve for L. So the L is here, and I have this 2W here, and then I have this 2 that I'm going to have to move. So the first thing we want to do is to move this 2W. So let me go ahead and rewrite this. So we're going to move the 2W term, the whole term. And so we're going to subtract each side by 2W. So on this side it's gone, and 2L is left. On this side we've got P minus 2W. Now the L is still not by itself, so what I want to do is I want to divide by 2 to get that by itself. And so when I'm done, those cancel out. Length is by itself, and I'm going to have P minus 2W divided by 2. And so that is simplified. Okay. This one I have V equals VO plus AT. We're going to solve for A. The first thing we want to do is to get A by itself. And when I look at this, I notice that I need to move this and I need to move the T. So I'm going to rewrite it. Plus AT. First thing I can move is I can move this VO. That's subscript O. V and V subscript O are not the same thing. So we're going to write it like this. Equals AT. I want to get A by itself. This is multiplication, so the opposite would be to divide both sides by T. So I'm going to get V minus V subscript O divided by T is going to be equal to A. And there it is simplified. We can't simplify it any more than that. Okay? Sometimes you have a fraction. So when we look at number 4, we've got Fahrenheit equals 9/5 Celsius plus 32. And they want us to solve for the Celsius itself. We can do the exact same thing, just to move it across. So we're going to take and rewrite it. To get C by itself, I need to move this and this. So I'm going to move the 32 first. And I'm going to get F minus 32 is equal to 9/5 C. Now this is where it gets a little tricky, and we have to think back to our instructions when we're dividing by fractions. If I am going to divide this, I'm going to take 9/5 and I'm going to divide it by 9/5. Now you'll remember that when we're dividing fractions, we're actually going to multiply by the reciprocal. So what that means is that the first fraction is going to stay the same. The division changes to multiplication, and the reciprocal, or the flip, of the second fraction. And when I do that, anytime I take a fraction and multiply it by its reciprocal, it's always going to be equal to 1, because the 9's will cancel out to 1 because they're both divisible by 9. And then the 5's cancel out to 1's because they're divisible by 5. And so then I get 1 over 1, which we all know is 1. So anytime you're dividing by a fraction, you're really multiplying by its reciprocal. So I'm going to multiply this side by 5/9, and I'm going to multiply this side by 5/9. So when I'm doing this, these cancel out. C is by itself, and I'm going to get 5/9 times my Fahrenheit minus 32. Okay? So just remember, when you're multiplying or dividing by fractions, we follow those fraction rules. And anytime it is multiplied and we're dividing, we're just multiplying by its reciprocal. Okay, there's a couple for you to practice with. If you have any questions whatsoever, please make sure you ask. Thank you.